This is a half-hour session, which means we get 25 minutes of talking, 5 minutes of questions. Please make Frank welcome.
Am I okay? Yeah, I'm okay. So today I'm going to talk about how to build an image processing pipeline in Python. So here is our little agenda. I'll give you a little bit of background to start with. Then I'll talk a bit about the architecture of the system we built. Then we'll get into the details of the different steps of the pipeline. So upload, image preprocessing. We'll talk a bit about OCR, and then parsing data, structuring data. And then finally, we'll talk about error handling, reprocessing, and then I'll open it up for questions. So let me give you a little bit of background about myself. So I started coding in Python in 2006 when I joined the YouTube team. YouTube is a big Python shop, if you don't know that. Recently I joined a little startup called Nginx.com, and so I'm going to use what we built at Nginx.com as a case study for this talk. All right, so what do we do at Nginx.com, and why did we need to build a pipeline? So it's pretty simple. We are basically providing digital coupons. You can think of it as offers. So what people do is they install our app, our mobile app, Android or iPhone, and then they get offers for buying product from specific brands. So let's say you can get offers for buying Mountain Dew or Yoplait yogurt, or we have a number of offers. And then the process is really simple. People can shop anywhere, any store, and then they snap a picture of the shopping receipt with their phone using our mobile app. And then we get that picture of a receipt on our backend, and we're going to process it. So that's where the pipeline does the work. We're going to process it, figure out what people bought. So we're going to extract the data from the receipt, figure out how much they paid for the item, figure out where they bought the item, the price, so on and so forth. And then we're going to give reward to users, so making hopefully users happy. So before we get into the details, I wanted to start with a little bit of fun. So as I said, I used to work at YouTube, and I used to watch a lot of videos. That was my sort of my job. I was paid to watch videos, debugging videos. And so I was like, when I decided to join Nginx, I was like, whoa, shopping receipts, that's going to be kind of boring, right? It turns out I was totally wrong. We are having a lot of fun actually looking at some of these receipts. So I have a few examples for you. So again, a lot of funny cat videos on YouTube, but we get cat pictures as well. So little kitty, very cute. On the right, that's a great one. It's a little bit hard to see on the screen here, but basically what we think happened is someone had a shopping receipt that was really wrinkled, right? And they were like, I kind of feel bad uploading this receipt as it is. It's kind of hard to read. And so that person came up with the idea to iron the receipt, right? I mean, it works with clothes, right? Like, you wash your clothes, they wrinkle, you iron them out. Well, the only thing is, it doesn't work so well on thermal paper, right? So it's kind of cute. Couple more examples. I think, you guys. You guys know we have laws, I think, in this country against texting and driving. I hope there is no law enforcement personnel here, but apparently there are people who take pictures of receipts while driving. And then the one on the right here, I still have to look up the username for whoever uploaded that picture. Might be David Copperfield or something, because it does look like it's a magician trick, like trying to take a picture of a receipt while trying to make it disappear at the same time. Kind of fun. All right, let's get back to technical stuff. So, picture of shopping receipts are fun, as I said, but they're actually also very interesting in terms of image processing. People take pictures, under various different conditions, like, outside, inside, whereas like, your finger is across the receipt. They use various different devices, so you can get like super high resolution pictures on high-end mobile phones like iPhone 5 and the latest Android. But you can get also crappy devices. Resolution of images vary. The quality of receipts, the print itself, varies greatly. And then another thing is, shopping receipts, if you think about it, it's actually not English, I challenge you to look at your receipt and try to figure out what's on there. But you have to look at it, twice to figure out. So let's talk a little bit about the overall architecture before we dive into the details of the pipeline. So a lot of people ask me, okay, what kind of technology are you guys using? So I'll just throw it here. We are a full open source stack. Linux, Nginx, Tornado. We are using Python 2.7. Redis for caching. The only non-open source thing we have is S3 for storing the receipt images. And then on the website, it's Mako. We store a lot of data in MySQL. Then in terms of a pipeline, we use OpenCV and NumPy primarily. A little bit of ImageMagick. It's like the Swiss Army, knife for image, filters and stuff. And then Tesseract for the OCR. And I'll give a lot more details about that. And then in terms of data mining, we store stuff in MongoDB and with some Hadoop stuff. So high level, right? So it's actually pretty simple, right? I like, keeping things straightforward. So our users are uploading these pictures to our backend. It goes through Nginx, so we use Nginx for load balancing. And then we have a cluster of upload servers taking these uploads, right? Taking these pictures. We run Tornado as a front end of these boxes, and we keep it like, again, super simple. The only job Tornado does is, basically writing the image on the disk, on local disk. And then we run the processing pipeline that's going to store the data in MySQL, Mongo, and then we store the originals in S3. So, fairly straightforward architecture. A bit more details, and we'll dive into each of these components here. So what's the pipeline, right? So we get, these images of a receipt, and then we're gonna, the first thing we're gonna do is pre-processing. It turns out if you feed an OCR engine with a picture, of a receipt, your quality is gonna be terrible. So you need to do a lot of cleanup. You need to do a lot of pre-processing before you can run OCR. So pre-processing, then we run OCR, then we do some parsing of the data. We try to make sense of the data, right? And then what we do is we're gonna score. So we're gonna score our output, because what we found out is it's actually really difficult to come up with a set of parameters that are gonna work well on all your receipts, right? So we basically run a multipass algorithm. We're gonna run through this pipeline multiple times with different configuration. Right? And at the end, we score, and we're going to keep the best result. Okay? And so the output is a structured document. Okay, where you see, we extract the retailer, the date, address, and then what items we bought, sales tax, total, so on and so forth. All right, upload. So a few words about mobile uploads. Obviously, it is a little bit tricky. Your data connection can be spotty, so people are gonna lose their connection while they're uploading. You're dealing with various, bandwidth rates, so uploads are gonna take, different, amount of time. The images are actually not small. If you look at the size of images, on the 3GS, iPhone 3GS, for instance, I think it's like, about 200 kilobytes. If you look at high-end devices, again, latest Android and iPhone 5, you're going to get images that are between 1 megabyte to 1.5 megabytes. This is all JPEG compressed, obviously. So how do you build something that's reliable, right? How do you build a reliable upload pipeline? Well, it turns out one of the key things to think about is make sure your app, can retry. Like if your upload fails, make sure that the app itself has some mechanism to retry with a timeout, right? So that you don't retry forever. Don't try to upload this picture in the background, on the phone for several hours. First of all, you can do that on iOS, for instance. You can run in the background only for, I think, 20 minutes. Simple retry in the app. And then, it turns out a very simple thing we ended up doing is actually, if the upload fails after a few automatic retry, just let the user know and let the user, press a button to retry the upload, but without having to take the picture again. Like dumb simple, right? They're on the road, it doesn't work, they come back home, they upload again, right? I mean, they tap the re-upload. How does that work in the back end? So, same thing. I like, when things are simple. So we basically have two APIs. We have one API to start the upload. And the only parameter, in our case, is the number of segments. So one thing I didn't say is, some of these shopping receipts, can end up being pretty long. So they don't fit on a single image, right? So we ask our users to snap a picture of the different segments, right? So an upload can have multiple segments, multiple images. So what the app does is that it calls this API, so it's REST, JSON, simple, and it says, I want to start an upload and have 3 segments. Backend is what we do is we use MySQL, we have an upload table, right? And we're gonna say, all right, there's a new upload, insert a row in that table, we get a unique ID, and we store how many segments we expect. We return that to the client, all right? And then the app is gonna call a second API, we call it the upload API, with that unique ID that got returned by the server, the segment number, and then the image. So basically it's saying to the server, hey, this is my upload for segment number 1, and here is the image. And then the server returns the list of segments that it already received. So in case there was a failure on the server, the client already always knows what the server got and can repeat uploading a segment if it failed. Right? So again, very very simple. Scalability. So we've been really happy with Nginx. We use the sticky session module. You don't necessarily have to use it, but it just makes it easy to make sure that a given upload gets directed to the same server, so that we get all the segments on one box. Super easy. It's cookie-based. And then, as I said, we have Tornado writing the payload, so the image files on the disk. Tornado does a great job at asynchronous I/O, so it's a good choice for this type of stuff. And then we have a Python job that picks up these image files once the upload is finished. And the first thing we do is store them. And I'll give more details later with that. And then we run the pipeline. Again, super simple stuff. We actually don't use a queue. We don't use RabbitMQ or things like that. When the upload is done, Tornado just writes a Sentinel file saying upload ready, upload ID.ready, it's a file. And then all what the Python daemon has to do is check for these files. Super simple, works really great. Okay, next in the pipeline. So image pre-processing. So again, why do you need to do pre-processing? Some people say OCR is a solved problem, and it is true. It is a solved problem, but in very specific conditions. It works really well on book scans, right? So when you scan a book under perfect lighting, great image resolution, no noise, no shade, nothing, it's great. The lines are straight, perfect. You get recognition rate in the order of 95 to 99%. And this is using open source software, Tesseract. But if you start giving OCR a weird document, like lines are wrinkled, there's noise, it's might be a bit blurry, the picture got taken under a weird angle, then it gets really confused. You see recognition rate dropping to 25% or less. Right? So that's why it's really important to do a good job at pre-processing. These are the pre-processing steps we take. It's all in Python. We use OpenCV and NumPy to do all these steps. First thing is, so we get color images. We transform them to black and white. We apply a few filters, sharpen it. We highlight the image. Turns out some people, before they upload the receipt, to make sure we process it correctly, they highlight it, with a pen. So thanks for helping, but not really. Yeah, we undo that. And then we run some adaptive thresholding. So basically, it's an algorithm that, takes the color images and makes it into black and white. And as opposed to using a global threshold for the whole image, it's going to use a threshold on the area that it's processing. Cropping, super important. I have like a little funny story about that when we built the system. So we are like testing in the office, and we also, and actually, we're wrong. I was actually looking at the pipeline at some point, and I noticed that some images were taking like way too long to process, like 30 times longer to process. And so I was like, what's going on here? So I looked at the images that a user had uploaded. And what it was is the user had laid the receipt on the floor, and it was a carpeted floor, right? And so there's quite a big chunk of a carpet all around the receipt that you could see on the picture. And it turns out, and at that point we didn't have auto cropping, right? So we were feeding the images directly to OCR. And what turns out is that actually the texture of a carpet is very similar to characters, right? It's like, so, you have these lines, and then when you extract contours, you have these, little, shapes. It's very similar to characters. And OCR was getting totally confused and finding like these thousands of characters everywhere and taking like way too long. So what we did is we wrote a carpet cropper, right? And then, so final step of the pipeline is extracting lines. Again, OCR is really good at extracting basic layout, but when the lines are not straight, it gets confused. So what we do is actually we extract ourselves the lines, and we feed our OCR engine with lines, as opposed to the full document. Okay, so this is an example. So on the left you see the original image. In the middle, it's the auto cropping, so extracting this yellow area, getting rid of the background. And then on the right, you see the line detection algorithm. The little boxes in green are the letters, and then the purple are the lines that we're going to feed to OCR. All right, OCR. So we use Tesseract. It's open source, C++ code base. Super old actually, but I think it was started at HP in the 90s, and now it's maintained by Google. They use that for their bookscan project. It does have some nice Python binding, so you can use that, or you can run it on the command line if you want. Now, out of the box, it comes with some training data. It just didn't work at all for us. Couple reasons. One reason is the fonts on receipts are actually not standard fonts. It's not like Times New Roman or these fonts that you find in your favorite text editor. These are like printer-specific fonts. So we sort of like had to train OCR as on this shopping receipt as if it would be on a new language, right? With new fonts. Very tedious process, by the way. And then the other thing we did is, we built some dictionaries that are specific to shopping receipts. Because again, it's not English. You're not dealing with English. It's a different language. So word dictionary, with a bunch of probabilities. Punctuation also is different. So a lot of training work to do here. Now, what happens after OCR? So basically, you got your text. There are some, notice there are some errors in the text because OCR is never perfect, right? You're never going to get 100% accuracy. And so what you want is, you want to extract the structure out of that. So basically, in our case, we wanted to find the store name. We wanted to find what item people bought, taxes, total. So how do you do that? So first of all, a little tip for you guys to avoid getting headaches is don't start with Regex. It's awful, right? I never, liked Regex, but now I really hate them. It just doesn't work on OCR text because it's really difficult to come up with a Regex that's going to work when there are mistakes in your input, right? It's like, it doesn't fit in a human brain. Now, an interesting thing is Levenshtein distance, right? It's a cool algorithm. You take, 2 strings. It's going to give you basically a similarity score. It's going to tell you how many, the number of edits between the two strings. So what we did is we took Levenshtein distance, and then we built our own little string utility. We call it the fuzzy matcher. As an input, it takes the pattern that you're looking for. You feed it with the OCR text. And as an output, it gives you a score. So it tells you, this line in the OCR, the score is like, one edit compared to what you're looking for. And so that's what we use to find patterns in the receipt and extract the data. Once the data is extracted, so first of all, we do have parsers that are specific per retailer because it's useful to know what you're looking for. So we have like a parser specific to Walmart and to Target, things like that. And then that's for the big retailers. And then for smaller shops, we use just a generic parser. We store the data in Mongo. It was super useful at the beginning because our schema was like changing every day. So we were running in production and we wanted to add new fields. You don't need to worry about that with Mongo. Yes, that's some MapReduce capabilities, even though we don't use it so much. It's more like for the schemaless thing that we used it first. Now let's talk about something very important. So things will break, right? I mean, that's for sure. When I look in this room, I only see great coders, right? You guys don't write buggy code, I'm sure. But I'm not so sure about your coworkers, your summer interns. These guys are going to check in some bad code. So just, when you build a pipeline, take the assumption that it's going to crash, right? Your servers won't stay up forever. They'll die. So how do you get, some good sleep at night knowing that? I guess I have 2 solutions for that. The first one is at night, before you go to bed, you open a nice bottle of red wine and you drink a glass, right? It works really well for me. I love Bordeaux 2005. It's a great vintage. You get some great sleep. The other thing that you can do is actually, right from the get-go, when you build your pipeline, figure out how you're going to store your originals. Never lose your originals, right? So these images that you get, the most important thing you can do is like store them, redundant storage, whatever, never lose them. Then make sure that you have rerun capabilities for your pipeline so that in case you get a crash, easy, you just have to rerun your pipeline. Like makes your life so much easier, and think about that when you start building your pipeline right at the beginning. Super simple, again, super simple tips. And I think we're going to open it up to Q&A. But before we do that, just one quick slide. I want to talk about another pipeline we built. It's all in Python. It's our hiring pipeline. You take a picture of your resume, you send it to us, and we have a Python algorithm that's going to figure out if you get a job or not. It's awesome. I'm joking. No, we do have jobs. If you're interested, check out our website, endorse.com. Thank you. Q&A.
Thank you, Frank. If you have a question, please come up to the microphone.
I was wondering what algorithm you're using for the line detection. Are you using stroke width transform, or what are you using there?
So the question is what type of algorithm we use for line detection. So it's something so there's a lot of research paper about that you can find online. So we built our own line detection algorithm. Basically, you have a set of characters, and you try to find, the best line. So sort of like constraint-based algorithm. Yep.
When it comes to the images that are, let's say, either tapered or fisheyed, do you do any sort of adjustments before you do OCR? And if so, how?
Sorry, I missed that question. The
images which, let's say, are tapered, let's say somebody takes, receipt looking kind of like that. or it's fisheye.
Oh, I see, got it. So I think the question is, sometimes you get some picture of receipt that are taken from an angle, and so what do you do with that, right? So what we do is, we run the pre-processing, and actually the line extraction algorithm is going to take care of that. So it's going to, it's going to figure it out and straighten up the light and make it, all nice before it gets to OCR. We get a lot of Star Wars receipts, right? So it's a great question.
Which part is the most problematic in the pipeline in terms of not working and in terms of accuracy?
So the question is, which part in the pipeline is the most challenging? It's a good question. Yeah, I mean, all these steps, I would say probably the pre-processing and then training the OCR. These are the most challenging parts. The parsing is tedious, but you get it done. Yeah.
And can you tell us what's the accuracy that you get at the end?
I really have to remember.
What's your overall accuracy?
Our overall algorithm?
Accuracy.
Accuracy, sorry. So, yeah, good question. So it really widely varies depending on the quality of the picture we get. So on the high resolution pictures, we get quality that are, 80 to 90%. On bad quality, blurry picture, it drops dramatically. So it varies quite a bit.
How do you deal with when people upload the same receipt like multiple times or?
Yeah, so the question is, how do you deal with fraud, basically? How do you deal with people trying to upload the same receipt or using different accounts? So, we built a fraud system, basically. So we look at different signals, time of upload, from which account it came from. So there's a bunch of signals that you can use to figure out, to try to flag, these uploads as fraudulent. Great question.
How are you passing data between different parts of your pipeline? Because I know OpenCV and NumPy, and they use slightly different formats for things. So what are you converting between them, or how do you hand off between the different stages of your pipeline?
Yeah, good question. So the question is, how do you hand off data between your image data at the different step of your pipeline? It's basically, so there's a great integration between OpenCV and NumPy. It didn't used to be the case, but now it's there. So we basically use that. So we keep it in memory. We have boxes with quite a bit of RAM, and it fits easily in there. So yeah, pretty simple.
When people upload their receipts, I mean, they're really giving you a lot of information. I mean, very personal information about themselves. What kind of challenges has that brought with what you're doing?
Yeah, so good question. So the question is about PII on receipts and privacy, right? So yeah, that's something we take very seriously. We do let, we have terms of use, making sure, we let know people, we're never gonna disclose your private information, we're never gonna share it with anyone. So we when we use the data to target some of the offers, it's totally anonymous. So it's similar to ad serving or things like that, where you get targeted, but you can never really pinpoint one particular user. So that's exactly the same thing we do.
Okay, it doesn't look like there's any more questions, so let's thank Franck again.
Thank you.